Okay, so continuing from where we stopped, stopped at the Maxwell equation and its complex form. Okay, moving a little bit further, let us take the two of them. Let's see how we can play a simultaneous equation with two of them. So if we take the curl of, let's call this 1 and this is 2. So if we curl both sides, or curl equation 1 on both sides, we get this. That is the curl of the curl of H is equal to J plus J epsilon E curl of E. Why? Because only the vectors that curl affects. Other guys not. Curl cannot affect other scalars. It only affects vectors. So it's going to only affect the E that was here. This E. So taking the curl, this will be double curl, and here will just be one curl on the E. And that's going to be curl of H plus J W epsilon into bracket minus JW mu H. Now your vector triple product has a formula. This is the formula for your vector triple product. You can research on that later. This is the formula saying that your grad in the bracket div of H minus H in the bracket div of grad is going to give you, and then when we open the bracket, J minus J, the complex J times complex J is equal to minus 1. Minus 1 times minus give us plus. So this is why we got this. Then from our equation above, we know that the div of H, which is div of B, is equal to 0. Therefore, div of H is equal to 0. And all we have left is grad squared H. So grad squared H is equal to J plus mu squared, plus W squared mu epsilon H, and then put in a minus on the other side. So that is for our H. Now let's look on to the E. So let's take it from the other side. If we take equation 2 and then we take the curl, and following the sequence we finally arrive at this. Now we know that curl squared or grad squared E is the same as d squared E with respect to a particular direction. Now I'm taking the z-axis as my direction of propagation. Why? Because that's what we drew here. You can see that it's going in the z-axis. Okay, so our direction of propagation in the diagram is z-axis, so I'm going to use the z here. Now this is the formula. D squared E over z is equal to minus JW U in the bracket capital J plus complex J W epsilon E. Now this is where we can differ for different situations. In free space, free space meaning there is no charge. Because there's no charge, it means there's no current. Because there's no current, then J cannot be existing. So in free space, we would have d squared E over the z is equal to minus JW U into bracket 0 plus JW epsilon E. Now, so this is 0, so we'll just multiply this term with this, and we're going to get squared E z equal to, now J squared is minus 1, so minus times minus is plus, so you're going to get mu squared, you get W squared mu epsilon E. So that is in free space. Propagation is free space. This can also be rewritten as let's just leave our d squared E the z as grad squared since it's easier to write. So we have grad squared E is equal to W squared U epsilon E. Alright, now we want to start deriving. So let's make our constant propagation constant. Now this is always constant. As you can see, mu is constant for a particular for a particular material. Now this is free space, so we have mu naught and epsilon naught. So W is also the change in frequency, is the rad per second. Yeah, the frequency of change of state, change of your amplitude, the wave. All right. So we have this as a constant. Let's call it this. So your propagation constant, which is gamma, is going to be your propagation squared rather.